Hello and welcome everyone in this YouTube channel. Today I want to share my knowledge regarding AD converter, analog to digital converter. This is a type of practical which we do in our MSc 4th sem. Today we are going to learn about this AD converter. Okay, what is an ADC? An ADC means an analog to digital converter. Okay, it is a type of analog to digital converter. Is a device that converts continuous and analog signal into discrete digital signal number. Here, our main work is to convert analog signal into a digital number. Okay, it sounds quite interesting, and let's see how we can do it. This experiment in our lab. The conversion process involves sampling the analog signal, quantizing it, and encoding into a binary format. We'll take a sample, we'll quantize it, and finally our result will be in a binary format. So I would like to take you towards the practical. Okay. Um, Let me go to the other. Okay. Document viewer. Okay. Okay. Analog to digital converter will see more clearly in this one. Okay. My handwriting is not so good, but just listen to the thing which I share here. Okay. I don't say myself a good in explaining this, but whatever I get a knowledge regarding this, I would like to share it to you. Those who are listening it. Okay, analog to digital converter. Okay, I would like to read it. Point was, a transducer is used to produce an electrical signal corresponding to a physical quantity. Okay, transducer is a device which converts electrical signal to a physical quantity. Physical quantity means non-measurable quantity. Okay, it can be measured, but it cannot be measured in the form of electrical signal. But this transducer is a device which is used to connect physical quantity to a electrical signal. Example, microphone converts sound signal to an electrical signal. Okay, this is also one type. Okay. Another is electrocardiogram. ECG produce electrical signal in millivolt range, whereas hydropower system produce in a kilovolt or a megavolt range. That means one of these produce in a very low range and one of these produce in a very high range. Another is thermocouple, also measures in a millivolt range. We know about thermocouple. Okay, if there is a temperature difference between any two point of this thermocouple, then the electrical current will be generated in a millivolt range. Another, hence, digitalization of the analog signal become mandatory nowadays. Okay, we need to digitalize. That means we need to convert analog signal into a digital signal. That has become mandatory nowadays. Okay, relation between analog number and a two-bit digital number. If we have a two-bit digital number, A and B, then what is the relation? We have a relation between analog number BA is equal to 2 power 1 A plus 2 power 0 B. Okay, this is the final result which we will get later. Okay, I'll explain it. First part, in our experiment, we have a different part. Okay, first part, second part. First part is production of reference voltage. Second part is comparator, and third part is interface, and fourth part is parity encoder. Okay, I would like to explain through this figure. As you can see here, this first part, okay, seems, let me pick a color. Okay, this first part is we are giving here 12 volt and we are using several resistor over here in such a way that we have used here R is equal to 5.6 kilo ohm. Okay, and here we have used R is equal to 1 kilo ohm, here 1 kilo ohm, 1 kilo ohm, and 1 kilo ohm, such that in this point, if we supply from here a 12 volt DC voltage, then we will get here 5 volt. Okay, I would like to explain you how we created here 5.6 kilo ohm. Okay, we have created 5.6 kilo ohm by taking any two resistor in a parallel. Okay, any two resistor in a parallel, maybe that two resistor is of 10 kilo ohm. Okay, if we take a 10 kilo ohm resistor, set that resistor in a parallel, then we will get here 5.6 kilo ohm resistor value, such that if we use all other part, if we use 1 kilo ohm, then we will get here the reference voltage of 5 volt. The question may be why, because this is simple circuit of voltage divider. We can use here VR means 4R divided by R1 plus 4R. Okay, this is the formula. If we want a voltage over here, then what is the value of resistance below it? 1, 2, 3, 4. 4 kilo ohm below it, and above it we have a 5.6 kilo ohm. That means whatever the value of resistance we have, okay, downwise, okay, we will divide 4 kilo ohm by divide by the total resistance in this circuit. 4 plus 5.6 is 9.6. 4 divided by 9.6 into voltage of DC is 12 volt. We'll get here 5 volt. Okay, not kilo ohm. Okay, we'll get here 5 volt. Reference voltage will get here 5 volt. Okay. Okay, I have explained it. And again, if you want to measure over here, we have a 3 kilo ohm, down and up we have a 6.6 kilo ohm. So we'll get here 3.75 volt, 2.5 volt, and 1.25 volt in such a way that this part can be explained with the help of this. Let me take it and draw it. Okay, I want to clear my drawing over here. Cursor, and I'll close it. Okay. I have discussed about this first one, production of reference voltage. Okay. I have explained this, and we have get here 5 volt. Another part is of comparator. Okay. Part 2 is of comparator. What we have done here is, from here we have got a reference voltage, and the reference voltage is taken to the comparator. This one is a comparator. Okay, we have taken 3 comparator here. I would like to explain it. For n bit flash AD, we need a 2n minus 1 number of comparator is used. For here, we need a 2-bit analog to digital comparator. So if we have a value for n is equal to 2, we'll get the answer as a 3. 2 power 2 minus 1 is 3. So we need a 3 comparator over here. Comparator is made up of IC741. Okay. IC741 is used as a comparator. If input voltage difference between the non-inverting and inverting op-amp is negative, okay, output of comparator will be low, minus 12 volt, and high if it is positive. I'll explain this, okay, through a diagram. We have a 3 comparator. Okay, we need IC7401. This is the 2 number terminal, this is a 3 number terminal, and output is 6 number terminal, and the above one we have a 7 number which will be supplied with the 12 volt plus 12 volt, and down one is a 4 number terminal which will be supplied by the minus 12 volt. As we can see, we can give this 2 number terminal to 3.75 volt. And what about this 3 number terminal? We will connect each and every op-amp. Okay, we need a 3 op-amp, and we will connect the 3 number terminal of each op-amp and take it to outside, and we'll connect here one potentiometer. Okay, now this potentiometer is of 10 kilo ohm. Potentiometer is a type of resistance which helps to change the value of resistance and get our voltage, because here is a 5 volt power supply is connected with the potentiometer, and after that this potentiometer gives a output here by dividing some voltage. Okay, we can increase or decrease this one. Okay, now I would like to explain about the connection of this potentiometer. Let me take a little bit thicker pen. So my system is slow now. Okay. Okay, let me draw here. In potentiometer, we have a 3 terminal. Okay, we have a 3 terminal in a potentiometer. It has been erasing now. Take it. Okay, in potentiometer, we have a 3 different terminal. We will connect this third terminal to ground. Okay, we'll connect this third terminal to ground. Okay, and we'll connect the first terminal to 5 volt, and we'll connect this to this overall circuit, the middle one. Okay, this is the circuit connection of this potentiometer, and we'll change it and set up the voltage. This voltage name will be VA. Okay, VA. Now this potentiometer will be connected to this 3 number terminal of each and every op-amp, and this helps to compare. Okay, it is a comparator actually. What type of voltage we are getting here? We are getting 3.75 volt. Okay, and here if we get the value less than 3.75 volt, then what happened? Okay, let me see that and explain to you once. Okay, if input voltage between the non-inverting and inverting op-amp is negative, okay, between non-inverting and inverting voltage is negative, output will be minus 12 volt. If it is positive, it will be plus 12 volt. Okay. It will be set up in such a way that the voltage difference, if it is negative between inverting and non-inverting terminal, then we'll get output as a minus 12 volt. Otherwise, we'll get output as a plus 12 volt. Okay. Now for this, we need to set up this value and change the value with respect to this 3.75, 2.5, and 1.25, because each and equal number of voltage will be supplied through this three number, and the different number of amount of voltage will be supplied through this two number. Okay, as we have already known, because we are giving from here voltage dividing, and here from here we are supplying a constant voltage by changing only one resistance over here. Okay. Now after that, we have connected 1 kilo ohm here resistor, and we have connected one diode here. Negative terminal is connected to the resistor, positive terminal is connected to ground, and we have connected 1 kilo ohm resistor. Now this is the third part of our experiment, that is interface. I would like to explain this in such a way that if the output is minus 12 volt, then what happens is this negative one will come through this diode. It will be forward biased, and all the negative voltage will be taken to the ground. So no any voltage will be shown here through X if the voltage is minus 12 volt. But what happens if the voltage is plus 12 volt? If the voltage is plus 12 volt, then what happens is this diode do not work, because if we supply a positive voltage, it will be reverse biased, and what happens is the voltage of 12 volt will be dropped through this resistor, and the output we will get here as a 5 volt only. Okay, in each and every case. Okay, in each and every case, we will change this value as we compare here whether the value is positive or negative. If the value is positive here, we'll get a positive result. If the value is negative here, we'll get negative result. All will be ground. If there is negative, this will be forward biased. If some comparator is positive, then we'll get here 5 volt. Okay, now we'll see the output of this as a X, Y, and Z. Now, the fourth part of our experiment is a priority encoder. Okay, we'll make a circuit of priority encoder. Why this circuit is known as a priority encoder is that if any one of the terminal is positive, then we will get the positive result. Okay, it gives priority to the positive one, higher voltage. So it is known as a priority encoder. So we'll take here 7400 IC. The number are given here 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7 will be ground. 8, 9, 10, 11, 12, 13, and 14 will be given by the plus 5 volt. Now, the truth table for the priority encoder is this one. VA, if the voltage is less than BR by 4, okay? Don't be confused about this BR by 4, R by 2, R by 4, and 3 BR by 4, okay? These are the voltage which we have brought here, okay? BR means reference voltage is 5 volt, okay? If we divide BR by 2, this is BR by 2, okay? Otherwise, the voltage is not, is set in such a way that we'll get the different amount of voltage. Now, in the observation table, okay, we'll get the value of X if the VA value is less than BR by 4. Okay, BR by 4 means if we divide 5 volt into divide by 4, we'll get 1.25 volt. If we make the voltage from here less than 1.25 volt, you will set up the potentiometer in such a way and measure the outcome of the voltage. It should be less than this. Then we'll get the result of X, Y, Z in such a way that it will be tends to 0, it will be tends to 0, and this will be tends to 0. As we can see here in this truth table, our outcome will also be in 0. And again, if we set the value of BA as a greater than R by 4 and less than R by 2, we'll get only the value of Z, the higher one, and we'll get the value of B, or higher one, other maybe 0, okay, according to this, BA and BB. Okay, we'll see only BA and BB. And similarly, we'll get the value of this and this. Okay, if we take the value of BA respectively as shown here, okay, greater than or less than, actually BR by 2 means reference voltage by 2, reference voltage by 4 multiplied by 3. We have got this all this voltage over here in our circuit, so it is easy for us to operate it. And after that, after we have got the value of A and B, we have one formula to convert it into the outcome of voltage BA, that is 2 power 1 A plus 2 power 0 B, and we will get this result. Okay, 2 power 0 means 1, and we'll get the result of BA. So by this way, we have converted the analog signal to a digital signal. So our work has been finished. If you have any type of question, then please leave it in a comment section. We'll meet again. Bye-bye.